a little bit of a story is I like LinkedIn, and I used to think it was crap, and now I'm converted that you can actually have decent business conversations and meet really interesting people doing interesting things. A couple of years ago, maybe 18 months ago, I was kind of like scrolling through, and I saw some very interesting experimental video, which was photogrammetry-based captures of streets and cars and stuff. And I noted that the company was called Everypoint, and I started following them and seeing what they were doing and then showing them to people and saying, this is kind of cool. This is like, since Apple put the LiDAR sensor on their products, nothing really has come from it. And I guess that was because the LiDAR sensor on the Apple products was a bit crap and low res and low, what's the word? Low dots. Please help me. But the results were improving. Every single time I saw something from this company, I thought, things are actually moving along. And photogrammetry has made leaps and bounds and is now definitely competing against your expensive LiDAR scans. And I then started to engage with this company called Everypoint, which kind of had a hard launch in March. And I've been talking to them since. And the stuff they do is the closest thing that I've seen to magic since I've started writing about CAD. And we tried to get Jonathan Stevens here today, but we couldn't quite pull it off, and I'm definitely going to try and get him to come back next year, because if this is where we're at after about 18 months of this, then I think we're going to see some pretty cool stuff in that time. So I'd like to introduce Jonathan Stevens from Everypoint, who's based in Seattle. Can you hear me?
Yep, I can hear you. Making sure my mic was on. I'm actually in Oregon. We had quartered in Seattle. That's fine.
Sorry. He's close to Seattle.
A lot closer than London.
That's true. So I talked to David Boardman, who's the CEO of the company, and then learned some information about where they came from, because for me it was like a brand new company, but in our industry, or in the industry in general, he's been operating a very long period of time, offering services to companies looking to capture site conditions and material that's stored in stockpiles around sites using various different technologies. And so I'm going to start my conversation with Jonathan, talking about stockpile reports, which is the origin of this story. And that's the company logo. And so, Jonathan, can you tell us a little bit about stockpile reports and what it does?
Yes, and thanks for the introduction. What I always like to start with stockpile reports, because Everypoint is a new name to everyone in the industries that we talk to, but in reality, stockpile reports has been around since 2011, and we are the same company, and this is where our roots of our technology is. And so stockpile reports, just to make it very short, is it's a vertically built integrated service for logistics and inventory of bulk management of management of bulk materials at scale. What that really means is that there's companies like this one in this photo that have large piles of crushed rock. They might have bark mulch, salt for roadways, all sorts of bulk materials. And we help them digitize the volumetrics of those piles to solve a bunch of downstream problems, such as knowing how much you have at any time in your inventory, knowing how much time left you have before you need to get more in an asphalt plant, because this is your ingredients to make fresh asphalt or concrete. So we actually, our end customer is typically the financial officers of a company, like a CFO, and because they need these numbers to run their financials at the end of the month, end of the year, end of the quarter. We also work very closely with the logistics and the supply chain end of companies, making sure that they have what they need on time. A lot of companies typically pay overtime just to make sure they have trucks rolling in with material, when often they actually don't need it right away. They might have much more than they realize, but since they haven't been able to digitize and track their inventory to a high certainty in the past, they always ran on, I'd rather have extra and pay extra to have that than to run out. So that's kind of the genesis of stockpile reports and Everypoint is building this company.
So what kind of technologies have you developed to kind of grab these volumes?
Yeah. So our mantra is every pile, anytime. We started with our first client in 2012 with an iPhone 4, and we digitized basically a stockpile that looks like this top left one by walking around in a circle, taking a video, capturing that stockpile, using photogrammetry from an iPhone video, and creating a stockpile report, a volumetric report. And since then, we've gone from people taking monthly, maybe weekly measurements to now daily, hourly, and basically, I want a measurement right now. I can get that measurement right now. So we're able to then track all sorts of types of piles and different situations, and give them the granularity of data they need to run their business. And so typically in the past, we would have companies use methods like, I don't have a good picture here, but they call it the scientific guess, where they would take a walking wheel around a pile, guess how much they are. This is a scientific guess in their arena, where they would mark bunkers and say, okay, if the pile comes out to here, we have 30 tons or 300 tons or 200 tons on this salt pile. They have these loader scales. Those were the high frequency measurement methods, and we all are not great at guessing and taking these scientific measurements. The loader scales or the belt scales were the best they had, but even those, if they're not maintained at a high cadence, would typically stray off of their accuracy over time, and then you'd compound errors, and then you would find out how wrong you were or how right you were on your inventory once or twice a year, when someone would show up with a laser scanner, a GPS backpack, and they get an actual measurement. And so what we were able to do is put cameras in hands. And so the first one was the iPhone, and you walk around in a stockpile and you generate a 3D model, looks like this, a report. And then we also wanted to solve a bigger problem. We wanted people to get data all the time. And so we have drones were added when they became easy in 2015. Since then, because of advanced drones, we're able to measure piles indoors with drones, with cable cams. We even have drones in on docks. And then a lot of companies are moving towards what we call installed cameras. And it's this little box here where they install a camera on some machinery, and then they're able to get an update on a stockpile every hour, every 15 minutes, whatever cadence they need. And that's where you start to get in logistics and be able to do fast turnaround of your measurements and make quick decisions, knowing exactly how much you have at that time.
Cool. And so what you're using photogrammetry basically to capture piles and then estimate the volume from the 3D mesh that you create.
Correct.
What kind of accuracy? What kind of accuracy do they get?
So we've done lots of testing. Most of the testing actually that we've published has been from third parties, because we'd rather people trust other people's words for it. But what we found was that the gold standard is LiDAR. You get millions of points. It's high accuracy. It's very expensive. And compared to LiDAR, we will be plus or minus 2% of the volume from a LiDAR scanner. And that beats GPS. And a lot of people think, well, the surveyor GPS is very accurate, but they're taking single points on a very complex shape, and they might be out there for 30 minutes, an hour on one stockpile, and shoot a few hundred points. And then they have stockpile volume that's a very basic shape versus photogrammetry. We're getting hundreds of thousands of points on a stockpile and using that to get your result. So when the iPhone came out with the LiDAR, that wasn't new to us. Everyone, I can scan objects with an iPhone with LiDAR. we had been scanning scenes and objects since 2012 with an iPhone. So we're not strangers to this, and getting accuracy.
And just to point out that, so Stockpile Reports is a company that's profitable, it's existing, it's developed this technology, and therefore it's a viable business within itself. But they're a technology development company as well, because obviously they're creating the photogrammetry stuff. And are we going to go into the Everypoint stuff now?
Yes.
So,
and one note is, all of the photogrammetry, all of the computer vision in the background is our own IP. We've built it all ourselves. It's not, we're not plugging in other people's software to make this work. There's not a team of people working data in the background. It's all automated. So we've built this engine that's just end-to-end automation.
So the next thing is Everypoint, which is the stuff I started to see on LinkedIn. How did you come about to create Everypoint?
Okay, so we like to call it the brains and the bronze, where Everypoint is the brains behind Stockpile Reports, which is that brawn there. That's the company that we've built that's out there in the world right now making an impact. But from day one, Everypoint was the goal for our company. If you put this in the scope and analogy of Amazon, they built a bookstore first. They didn't try to solve every problem at the start. And so they built the Amazon bookstore to prove people would buy things online, have it shipped to your house, and that became a viable business. With Everypoint, we had the vision that people would be taking images all the time. We saw the iPhone come out about the time we started, and people were taking photos more than ever. We knew we could solve problems from imagery, but we needed to prove in the marketplace that people would actually do it and there would be an actual viable business around that. So we built Stockpile Reports as our bookstore, and then Everypoint is the brains behind that. Think about also with Amazon, you have AWS that powers Amazon. Well, Everypoint powers Stockpile Reports and powers a few other applications now. So that's the motivation. That's the genesis of Everypoint. Was from the beginning, we had the vision that people will be taking photos, will be extracting data from it, primarily 3D data you're seeing at Stockpile Reports, but all sorts of data we can extract from images. And that's where Everypoint sits. It's that brain behind everything.
But it's got a generic application. So we're now leaving stockpiles and we're looking at, can you use these devices for doing more than average LiDAR scanner, or can you, what's possible with this kind of technology that Apple has given us in these phones?
Yeah, so when we saw the LiDAR come out on an iPhone, that was when we really started launching Everypoint, knowing that people are going to be scanning things now with an iPhone because they made it easy. So we jumped in and we quickly figured out what's the maximum 3D capture technology we can get from an iPhone today. And so I have a couple of videos. I don't know how well they'll translate on your screen. If I just freeze frame it here, what we do is, this is just photogrammetry, and this is what you would expect using photos on shiny objects. This is just a furnace and a water heater kind of on the side. That's what you typically get using just photogrammetry, unless you do something special like spray coat things, but people don't have time for that in the wild. You have a bunch of construction workers out there, they're just going to take photos and move on, or videos. So we are able to do what's called LiDAR fusion, and we merge the depths that come from that LiDAR sensor with photogrammetry output. We're able to preserve all the detail, but still recover all those blank surfaces, the shiny surfaces, and you get these really detailed scans from an iPhone with the LiDAR on it. So this just kind of shows the difference of the two and all that you miss. And that LiDAR is just basically an extra sensor to give us more information about a scene. So if I move to the next one, this one I can freeze frame a little bit as well. So when you're using a LiDAR, as Martin, you pointed out, it's low resolution. It is not the same LiDAR that you're getting from a Faro scanner or a Leica scanner, one of those high-end scanners that's going to shoot millions of points. It's just a lower resolution scanner. But Apple built it to scan a room, to put what we call a dancing dinosaur on a tabletop. It's for AR experiences. It needs to approximate where surfaces are. You can focus faster on people. And so when you're using just raw LiDAR and you want to mesh it, it'll do a bunch of filtering. It's going to look for flat surfaces. This is what you get. This is a pegboard that's up in my garage, and it's, you know, it's very flat. It picked up some items. You go back here and play this, but you can also turn off that filtering, and again, you're getting a very low resolution scan. It's picking up some bumps. These are tools on my pegboard, not looking great. And then if I move forward, here's the raw LiDAR output. It's noisy. You can see, okay, I can see there's a drill, a hacksaw, an axe. You're starting to see some things, but it's not very sharp. That's because it's just that raw LiDAR. And there's companies that have done things to kind of get the best out of that, but still, they're always lacking in some detail. Oops, so apologies for this sharing on here. But so what we do is, again, is photogrammetry first, and then we're using that LiDAR to fill in a bunch of holes where there might not be a lot of texture, and then we're able to get lots and lots of detail on a scene. So that's showing now. You can see all the tools. All, you know, now I know what everything is, because we can push the density of these point clouds up very high, especially if you get close to objects with an iPhone. Oops. And then again, because we're using photogrammetry and LiDAR, we're able to get much further out. So you're not constricted to that 5 meter range that you see with every other app, because we're actually using photos to fill in further away objects. I mean, like the top of these trees are getting captured. And this scene here was captured again with I think this was an iPhone 12 Pro at the time we were doing this. And just to see, can we do a full house? We can process this on the cloud. We can process this on the phone, on an iPad. It does take a little bit of time on device, but you can do it. And so now you got this really powerful tool in your pocket.
Cool. So that took you up when you were using the iPhone 12. So that was pretty much when I started seeing your stuff on LinkedIn. So we've got a few more years worth of development that you can demonstrate. So we looked at the iPhone, and while we were happy with the LiDAR, we've been less impressed with the density of the meshes. So how have you overcome density in terms of creating a mesh?
Yeah, and so here's a couple good examples of just dense. I was trying to find some architectural examples. Both of these are dense. Both of these are further than 5 meters. And when you use photogrammetry, if anyone who's ever used this before, there's a pixel to pixel density to distance. So if you're close to an object, you actually have quite a bit of pixels on a camera. In fact, they just released a new version of ARKit on an iPhone that lets you get even higher resolution imagery while running the LiDAR simultaneously with video, and we're able to get a lot of density on objects. And so like this scene here, this was just someone, this is actually, I picked one in London. Person's walking around this building, and they didn't need to use a selfie stick or a monopod to get these upstairs windows. And we can push that density up. And then if you need to get, let's say, a point every 5 millimeters, there is a distance threshold, but we can help people figure that out. And then there's other tools that we can use with our engine. So Everypoint, although we have the LiDAR app, you can throw any image you want at it. So you could use a drone, you could use the iPhone, which is great because you can get all those blank surfaces filled in. Just any sort of camera you can think of, you can throw in the mix to get the complete scene. So I could have easily flown a drone over this and filled in the rooftops, but the ground parts with the overhangs, things like that, get those close-up details with an iPhone. And we can always just merge that all together because we have tools, we have targets, things like that you can use to register all this data together automatically.
And so one of the odd things about Everypoint was that they didn't really want to talk about Everypoint because it's very early days, and they're kind of swamped already with people approaching them for projects and working with them. But I kind of twisted their arm to try and open the kimono a little bit today. So the interesting stuff that you've got here is that you're combining photogrammetry with the point cloud from the LiDAR and the AR kit together. So you've got 3 streams of information, which gives you increased accuracy.
Yes. And then we also do a few other things. So when you're going to get a fairly good accuracy just alone on the iPhone, but when you really need accuracy, which we'll jump into in a few slides here, we use targets that you can lay out for control. We automatically detect the targets in our engine and say, okay, I see that tag, I see that tag on the wall. And then you can pass dimensions to it saying those known targets should be this distance apart. And then it'll always ensure that then the data is final scale corrected. And you're not doing anything on a desktop. At Everypoint, our goal is all this technology just happens. Like you scan, you upload it, you get what you need back. You're not sitting there working the data after the fact. And that's something we can do to tighten up that accuracy quite a bit.
So what kind of accuracy are you getting over a typical LiDAR scanner?
Okay, so again, I like to look towards other people's accuracy verifications and not ours. And so one of the first companies building on top of Everypoint is called Recon 3D. It's a forensics company that has launched this app called Recon 3D, if I specify a little better. And he himself has done accuracy studies, and so has some of his users. And they all fall within the same threshold. So what they've been doing is scanning cars and different scenes using Faro scanners. I think one person used an RTC 360. So some of the better scanners on the market to then do a side-by-side comparison. And with photogrammetry, it's not every point's gonna be exactly the same error. You might have some error over time that we can correct using, because this photogrammetry, we can correct a lot of error with doing multiple loops around objects and what's called loop closure. So we're able to go backwards and fix a bunch of problems with accuracy issues over time. But what this is showing here is that this is an accuracy against their high-end LiDAR, and this is showing 71% of the points were within 9.7 millimeters of that LiDAR scanner. This is one scan. This guy, it's hard to see in this. It's about the same. You're getting 70 to 80% within that. And there's also some of their points they point out. There's a few studies. So if you reach out to me, I can point you out to some videos where they show these studies and how they did it, and they walk through the whole thing, and they have written literature. But there are some points that don't line up because of how it was also scanned. So like around wheel wells, where areas just weren't seen as well in one scan versus the other. But still, a high percentage of those points are within 10 millimeters. So and when you're looking at an iPhone, just LiDAR, you're easily getting into centimeters to inches to feet if you go long distance, and we can keep this over long distance.
So you're saying that you can use an iPhone as a replacement for a LiDAR scanner, basically, especially a lower, maybe a 15 grand laser scanner. Right.
Yeah, we're seeing people right now. We actually have users who are they are actively working to replace BLK 360s. They like the scanner, but they're also trying to get higher frequency capture of data. They're trying to get more users using it, and it becomes a scale issue. So, and they also don't need accuracy, beyond this. They are doing pre-construction. They need to know where things are, how much space they have between two pieces of machine, but they also don't need to know down to the millimeter. They need to know down to, 3 centimeters or 5 centimeters. And they also need to know for cable runs, things like that. And they're able to then put iPhones and a bunch of technicians, in their pockets, and they can go scan every day, every hour. They can scan when they're done doing work to get an update. And so this one thing this unlocks is just the cadence in which you can capture data goes from you have one technician with a $15,000 scanner who can be only in so many places at do so many scans to, well, now you can put one of these in virtually everyone's pocket An iPad Pro in the United States is $800. It seems like it's going down in price as new models come out. You can always buy the last year's model, and the iPhone and the iPad are work just fine.
So yeah, I think this is the thing that kind of struck me is that essentially an iPhone on every person in construction on site is a scanner, and it's like having the equivalent of maybe a BLK360 in your pocket, and so there is no excuse to capture as built when everyone has the ability to scan it. And all you're doing is taking a video, it's taking the information from the LiDAR scanner and the AR kit and all that information, and it's capturing data live. There's no special training. You're just essentially, you're being a spot robot for the scanner by handing it around. So I kind of think that there was a phase change coming around because, okay, Everypoint is new. Everypoint isn't a product that you buy. It's something that developers will develop on top of. So it's coming. So I'm expecting maybe Topcon or some of the companies out there to actually build stuff on top of this to fill in from the high-end laser scanner world where everyone has a phone and everyone can capture 3D. I mean, I've talked to, I don't know if Harry's here, but Genza were working on an airport, and they told me it was taking weeks for them to get the first survey back. Well, now you can just send 10 folks to walk around with their phones and grab that real-world environment that you might be doing some augmentation to, and then start immediately as soon as that comes back to the office. You're not having to wait for super accurate surveys. So I'm kind of excited by this because it just means that everybody is empowered. And we've been waiting for a very long period of time to have devices which can capture accurate 3D, low cost, and have them just ubiquitous, almost ubiquitous. So that's why I'm excited about when I've seen Everypoint and talking to Jonathan and seeing what they're doing. And this is really early doors stuff. This is, God knows what you guys are going to be doing by next year in terms of the development and maybe the next iPhone and the features that are coming out. But the other thing on top of that is the new AR kit from Apple. So is it possible for you to talk about that a little bit?
Yeah, I'll see here. I think I have to flip my order of slides here.
Okay.
A couple notes on that as well.
We'll come back to that.
So here's the room plan. So I had these out of order. My apologies here. So Apple released this. It's not out on everyone's phone yet. It's called Roomplan API. And I would like to call it BIM Lite or LOD 100, maybe half of that, 50. I'm not from the AEC world as I'm learning, but you're literally able to walk around your room and it will build a very lightweight planimetric or parametric view of your room. It'll identify objects like desks. It'll identify objects like screens, all sorts of different objects. It'll give you some dimensional components. I'm not finding that it is super accurate, so I wouldn't go and scan a room and say, okay, I know down to the millimeter where things are. But again, Apple, their main consumer is not AEC. It's augmented reality experiences. It's fun and entertainment, but they also recognize this can be useful for getting basic dimensions on a room. And why we're really excited about it is, and here's the bathroom in my house, or one of the bathrooms, where it will capture all sorts of data like your windows, door openings, walls. So it kind of gives you some basics of where things are. And they also, it's hard to see up here in my screen, but they also then nest these. So like the windows are nested in the walls, and I can take it into software like this and just have it automatically remove all the furniture, and you're just left with walls, windows, and openings. But then our plan for Roomplan API is to help users scan more complicated rooms, because it's very easy to scan an object. I could walk around a table and walk around a statue. It doesn't take a lot of effort. And then scanning the inside of a building, well, it might take a little bit more effort. And if we know some basics, okay, here's the walls, here's roughly how big they are, here's some big objects in the way, then we can guide you how to better scan a room. And if I go back one slide, it might say it says point camera to the bottom edge of the wall. And so it gives you some on-screen cues of what you're supposed to do. And that's what we can also do. We can help guide you. You know, maybe you walk around, you know, a construction site and get the basics of the walls. And then, okay, now I'm going to go get a high detail capture, and we can guide you through the best path to get through there efficiently and making sure you get the data you need.
Because the interesting thing, in our industry, that we all want scan to BIM, and scan to BIM has never really been available. It's a completely artificial construct. Yet I kind of see that we're at the beginning points here of having that capability. You know, even though the stuff that Apple's working on isn't necessarily understands it's a wall or a door or has an IFC tag, you could stick that model in something like BricsCAD and run BIMify, and it would recognize holes and say that's a window, that's a door, and it'll give IFC tags on anything. So the potential for having a more automated workflow from dumb information to a BIM model is just so close. I feel a little bit too excited, even though it might not sound it. But there is something happening in this mobile world which is really something that I've been hoping for probably a decade. So the last thing I kind of jumped the order that I agreed to talk to you on. But so the other thing that Jonathan's been posting a hell of a lot of recently is something called nerfs, and I will leave that to Jonathan to explain because it seems like magic.
Okay, I think I got the and hopefully you guys don't get blasted with the sound on my computer. I believe I muted all these. But a nerf, you might, if you follow me on LinkedIn or Twitter, you're going to get this all day long from me. I've been diving into this. It's called a neural radiance field. Came out 2 years ago, but really a few months ago, it became tangible for someone like me who doesn't have very high-end compute clusters and 3 days of wait time to compute one of these. But what we're able to do is take a sparse, they call a sparse set of imagery. So here you see my, I think it's going to play again. You have a set of images input, and it's sparse. I might have 50 images, I might have 100, but not a lot. And then I'm able to create what's called novel view synthesis. So now I can look at this scene from basically any direction within some threshold of those cameras, but basically I can say take 50 photos and then move about the scene. And right now this is rendered as a video, but you can also interactively jump into what's called a GUI and look around this scene. And so you see these floaters, those are just the light fields, but it's just a new way to look at a scene, and it picks up specularity, which is like the reflectance of light off of objects from different angles. So this nice looking Ferrari, as you move around it, you're capturing the reflectance of the object. It looks like a very detailed 3D model that I've generated, but it's not. And I'll jump into that in a second. But that's where the confusion is for the BIM and the AEC community and all that is, oh, great, now I want the measurement. This is actually giving you just high quality views, and you can move outside of the 10 pictures you took of this car and look at it from whatever angle you want and see even the windows are getting reflectance. So if I move forward, we saw this view and this view, but if I was to move to the back of the car, I get this view, and it looks really odd because what's happening is I have this car here, and I took a bunch of images. Really what it was is a video when we walked across the Ferrari, and then what it does is it uses AI and machine learning, and it trains the scene to figure out what it looks like at all those angles. And then what it does is it creates a radiance field. And so you have, this is called radiance field. What you're seeing here is all these locations are basically called voxels. Think of like a bunch of dots, an infinite amount of dots. Each dot has a color and an opacity or a density, as I like to say it. So at any given spot, it is green, it's brown, it's blue, it's one of those colors. And there's a density factor. So it can be transparent, it can be semi-transparent, but then what happens is then the software casts light rays through the scene, and as it's going through the scene, You know, like if I put enough semi-transparent pieces of glass together, like if I took three, I try to think of like Carlsberg beer, it has the green bottle, or I take like enough of those bottles and put them in front of each other, it becomes solid because all the light can't make it through all the green pieces of glass. And so that's what's happening here. Light's casting through the back of this car into your camera, and it's hitting all these colors, and eventually the opacity will stop it and make it look solid. And so if I try to mesh it, it looked solid, but it's kind of Swiss cheese. Um, here's a lighthouse. Again, it doesn't look great. The colors aren't mapped. But I can tell you this technology started 2 years ago, and they've went from 3 days and 4 high-end GPUs to process 10 seconds of video or outputs of views to you can train these in minutes. So the speed of innovation has really gone fast. And there's people who are now working on how to make better 3D models from it, how to make better textures from it, and how to get those BIM models. And so I tell people, keep an eye on it. So these are two I'm going to show you. This is used in 360 video, and someone just flew a drone around the scene, and then you can move about the scene in any way you want, look in any direction you want. And unlike photogrammetry, where you never capture all the background, all the the mountains in the background, it keeps it all in frame. So now I can explore the scene at free will through a nerf, and everything still looks accurate. And so I think about it as, imagine if you had a robot roving through a construction site once an hour, collecting 360 imagery or 2D imagery. It doesn't have to be 360. Oh, there we got some sound. And here's another one. We're walking through this alleyway. You're able to do basically a 3D walkthrough. So think of all those 3D walkthroughs of real estate properties now, and you have like maybe 2 positions in a room you can jump between. With the nerf, you can move anywhere within that scene, and everything will look correct if you get enough images. And it's not as many images as you think. So it's just a way to then explore a scene and get much more spatial awareness of the scene after you've taken some photos. And since it trains in minutes, you could upload the data and have one of these virtual scenes within a very short time.
Super cool. So how big are the files that the Nerf thing makes?
Oh, they're small. That's what's crazy about them. Oh. So there's those scenes you looked at, you have the source images, and then it trains the scene and then outputs new images. And so if you're just interactively looking within a trained nerf, everything's fairly small. If I put in 500 megabytes worth of images, the nerf, when it's trained, is not much bigger. And then you could export infinitely more images out of there, and that could get kind of large. Or you can kind of have a live nerf going and just go through it right there.
Do you see that we could mix nerfs with photogrammetry, LiDAR, all together at different in one scene, or is a nerf not really that applicable to being?
I think we'll get there. This week is Computer Vision Conference called CVPR. There's a lot of papers came out in the last few months for that, and you're seeing people do things such as segmentation of the scene. Mm-hmm. So now I know where all the lights are, or I know where all the chairs are in the scene, and they can remove them from the nerf, which is incredible. So you can visualize now a scene without things in the scene that were there originally. And then they're also, of course, looking at how can you inject objects then into the scene and replace those. So it's a very much a visualization tool today, but it is quickly changing and quickly evolving. And that's why we are staying on top of it, because it's just one more way to have spatial awareness of a construction site, I'm thinking of safety manager wants to virtually walk around a rock quarry and make sure everything is being maintained properly. You could just have literally a robot roving through that quarry every hour, and you can generate a nerf at the timestamp you want off this imagery, and then go look at it.
So cool. So I think we're running out of time, so I'd just like to thank you, Jonathan. And yeah. I recommend following Jonathan on LinkedIn, because he posts relentlessly nerfs and 3D scan data, and they're always fascinating to look at the current state of play.
If I just leave you one thought, by the way, it's just Everypoint's, if you work with us, our goal is to have these Everypoint nodes is to get the answers without you having to do data. So think about machine learning as hitting us heavy with all this data. So pretty soon you're going to go through an AEC site, construction site of a building, and you're going to know all the links to the pipes, where they are two going to intersect eventually, all of that. And it's all going to be driven by 3D data, machine learning, 2D data, all of this. So yeah, reach out if you have questions, for sure.
Cheers, Jonathan. Does anyone have any questions? Ooh, I'm going over to Fabio. Yeah. Thank you.
Hello. Thank you for the very interesting presentation. I'd like your views. How far are we to start to use the nerfs, the video in 3D, connect with metaverse when we have all in the cloud, people collaborating, communicating, using real backgrounds, let's say?
I would say within a year or two. We're already at Everypoint looking at how we can start using it now in a limited fashion. So we have cameras set up at sites already, how we could capture 16 images every hour and then create a nerf someone could explore online. I think you won't see a lot of companies using it yet, but the amount of money and resources Amazon and Google and all those big companies are putting into it, and NVIDIA, I would expect within a couple of years, we're seeing them actually making it into products more often.
Any other questions? Okay, cheers, Jonathan. That's fantastic. Thank you so much for getting up early this morning in Oregon.
Sorry, I couldn't be there in person. I tried.
Yep. Come over next year. So,
all right.
Catch you later, and thank you so much. Cheers.
Thank you, everyone.